Assalamualaikum and very good day everyone. Now we want to explain about what is distillation column in chemical engineering. Our team members are Abdi Rashid, Lukman Hakim, Muhammad Fajar, Muhammad Farhan and Rahmat Agung. This is service learning to fulfill the requirements of separation process SKTK 3323 section 01.
So, what exactly is a chemical engineering? For the basic definition, chemical engineering is a multidisciplinary branch of engineering that combines natural and experimental science. So, basically, chemical engineering, the process, the transform and operate the raw material into valuable product. Let's move on to chemical engineering fields of job we can work as chemical engineer after we graduated. In this slide, I just only show you the popular one, which are food processing and petrochemical. Actually, in chemical engineering, a bunch of industry we can work, for instance, pharmaceutical, alternative energy, biomedical and biotechnology, chemical products, and etc.
And now we move on to the overview of chemical engineering in daily life. Most of the items you use on a daily basis have likely gone through a chemical process on their route to you. The fruit that you eat, the TV that you watch, and even the clothes that you wear, every one of them has at least gone through one engineering process. You can also do chemical engineering practice in home, such as when you make tea, you apply thermodynamics law, and when the tea comes out from the tea bag, it applies the principle of extraction. And when you cook with a pressure cooker, thermodynamics and energy transfer plays a role here. And when you make a cookies, it is actually a batch process when you want to make something that is not continuously. Almost everything that you put in your refrigerator has gone through some sort of technical procedure. Biochemical engineering has made dairy products and fruit juices. Live yogurt, for example, has the necessary bacteria, and fruit juice, despite the fact that it's most likely made from concentrate, is quite healthy. So what does a chemical engineer do in real life? They conduct research to develop new and improved manufacturing processes, where they apply new and improved technologies to ensure a more reliable and cheaper process in industry. They also establish safety procedures for those working with dangerous chemicals, ensuring every person is exposed to a minimized hazard. They also design and plan the layout of an equipment to fulfill the need of each unique plant. When it comes to daily routine, chemical engineers troubleshoot problems with manufacturing process to make sure the plant runs smoothly with minimum hiccups. They also evaluate equipment and processes to ensure compliance with safety and environmental regulations. It is compulsory for a chemical engineer to comply with every regulations to protect the environment. And when it comes to a new project, chemical engineer estimates production costs for management to make sure that the production is reliable enough to be produced in economic way.
And now to the distillation unit. What is actually distillation? Distillation is a method used to separate a miscible, binary, or a multiple component feed into two or more fractions or streams by utilizing the difference in boiling point or volatility of the components. This method is mostly or mainly used to separate homogeneous fluid mixtures. And now let's discuss some types of common distillations. The first one is simple distillation. It's used to separate liquids from solids or non-volatile components when the boiling temperatures of the two substances are considerably different, a minimum difference of 25 degrees Celsius. The second type is fractional distillation. It's used when the boiling points of the components of a mixture are near to one another or close to each other. It involves several vaporization and condensation steps, which takes place in the fractional column. It is also known as rectification, which is a succession of distillations. The third one is steam distillation. It's used to separate heat-sensitive components, and how it's separated is steam is added to the mixture, causing some of it to vaporize. This vapor is cooled and condensed into two liquid fractions. Sometimes the fractions are collected separately, or they may have different density values, so they separate on their own. An example is distillation of flowers to yield essential oil and a water-based distill. And the last one is vacuum distillation, used to separate components with higher boiling point. Boiling point are reduced when the apparatus pressure is reduced, that is the environment pressure. The method is used to obtain high purity samples of compounds that are decomposed at high temperature.
How the process of distillation? As we can see in the right figure, there is any distillation column to provide the distillation process. The process first beginning in the furnace to heat the liquid mixture before going into the distillation column. After the liquid mixture getting heat or reach the boiling point, then flow into the distillation column. As the liquid heats, component with the lower boiling point will begin to vaporize and rise through the column. However, the vaporizing will still contain some molecules of the other substances. Vapor gets purer the higher it rises in the column, as heavier molecules fall off and turn back to liquid. As vapor rises in the distillation column, heavier molecule will condense back into a liquid and run back down. As we can see, the bottom's liquid will be reboiling again, steam condensate. The product can process again can go to the distillation column, and the good product will go to the storage as the bottom product. At any given point in a fractionating column, vapor will be rising, liquid will be falling, and molecules will be mixing. Columns naturally have a certain stages, like the figure left. In every stages, any bevel caps for the holding the liquid as a product in every stages. However, the columns are designed to be tall enough to achieve a certain percentage separation by finding the minimum number of required stages. Vapor reaching the top of the column distillate is collected into an industrial condenser. The top product will be going to the condenser to condense and going to reflux drum, and the good product will go to the storage as the top product, and the product can processes again can go to the distillation column. The substances remaining in the column continue the process of distillation to get the properly separated.
Okay, now I will explain on the application of distillation in industry. The first application is petrochemical fuels and related products. The production of gasoline, diesel, and other fuels and chemical is a very important industrial application of distillation, amounting to many billions of dollars worth of processing annually. The process feeds crude oil, a combination of many substances, into one end of the refinery. Each distillation step removes a lighter substance such as kerosene, gasoline, and lubricating oil. The second application is pharmaceutical industry. In the pharmaceutical manufacturing, the purity of chemical substance is crucially important. At the same time, drug makers want to produce that are consistent in quality and which can be manufactured in industrial quantities economically. Distillation is one process that gives pharmaceutical companies tight control over purity and consistency. The next application is fragrance and essential oils. Vacuum distillation is useful for extracting fragrance from plants and other biological materials. These substances are fragile and can break down at high temperatures. So, vacuum distillation is well suited to obtaining them from natural source. Scent oil find their way into soap, air freshener, and other household and personal care products. Some of the beverage industry use distillation in their production equipment, especially in the production of liquor.